Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about integration by parts, right? So let's go ahead and get started, guys. So if you've seen the previous videos on integration, you must have seen that I'm only integrating individual functions. Let's say I'm integrating just a singular function like f of x, or I'm integrating f of x plus g of x, sort of these kind of functions that I'm integrating. So till now I haven't integrated a product of two functions, let's say f of x and g of x dot dx. I have not integrated the product of two functions. I've only done integration by substitution, wherein we integrated f of x and f dash of x dot dx. We actually used to perform integration by substitution in this case. However, if you have two functions where they're not the derivatives, where one is not the derivative and one is not the function, if you get something of this sort, then how do you integrate here? Let's say, for example, if I ask you the integration of 2x into e to the power x dot dx, right? Now, as you clearly know that the differentiation of e to the power x is e to the power x, that means these two functions are completely separate from each other. So if they are separate from each other, that means they're completely different from each other. How do we integrate here? There's no formal way of integration. There's no formal method for integration in that case. So we're going to talk about the product rule of differentiation first. So what is the product rule for differentiation? So if you've watched the differentiation videos, or if you learned differentiation in school, you would know that if I have to differentiate a function, product of two functions, u and v, you actually get u out and you actually differentiate v, and then you get v out and then you differentiate u. So this is the product rule for differentiation. So what I'm going to do here is, step one, I'm actually going to integrate both sides with respect to x. So what I'm going to do, I'm going to integrate both sides with respect to x. This dot dx, this dot dx, and this dot dx. So what I'm going to be left with right here. So here, as you can clearly see, this is the differentiation of integration of something that would simply be the function itself, because as you know, so I'm actually going to keep the notes here, like the differentiation of the integration of differentiation of a function is actually the function itself. This is something that you should definitely know. So that is going to give you the function itself, that is equal to, now if I just equate this equal to the integration of, you have u, right, you have u into dv, right, because this is dv, plus because this dx and dx gets cancelled out, and then you're going to have integration of v into du over dx dot dx, right? So I've just done some steps right here. So what I'm going to do here is, I'm actually going to do another step, that is uv is equal to u. So what is the integration of 1 dot dv? 1 dot dv is actually going to give you simply v. So that means here I'm going to have 1 dot uv is actually going to give me. Now we're going to talk about the first of all, we're going to be talking about the product rule for differentiation. So what does the product rule for differentiation state? Okay. So the product rule for differentiation states that if you want to differentiate two functions, let's say u and v, so first you actually keep u outside and differentiate v. Then you keep v outside and then you differentiate u. Fine. Now what I'm going to do is, step one is actually, now what I'm actually going to try to find is the integration of all these functions. So what I'm going to do is, I'm actually going to integrate both sides with respect to x. Of course, I'll be multiplying dx, all the sides, dx and dx. Now this thing over here, as you can clearly see, is the anti-differentiation of differentiation of uv, which is actually going to give us uv. So the anti-differentiation and the differentiation of uv is actually going to give us uv. So what I'm going to do right here is, I'm actually going to write uv, which is actually equal to that is equal to the anti-differentiation of u dot dv over dx dot dx plus anti-differentiation of v dot du over dx dot dx. Now what I'm going to do is I'm going to say, let's say u is a function, let's say u is a function of x. And you can clearly see I have dv over dx here. So I'm going to say, let's say dv over dx is another function of x. So then this is actually going to become, this part over here is going to remain uv. Basically it's going to become, u is going to remain, again, u is going to remain as u, that is f of x. And v is going to become, now if dv over dx is g of x, and from here you can clearly see that dv is equal to g of x dot dx, and if I integrate on both sides, I can say that v is equal to integration of g of x dot dx. So that means v is simply going to be equal to the integration of g of x dot dx. Now that is equal to the integration of u. Now what is u here? U is something which is f of x, and dv over dx is simply going to be equal to g of x dot dx plus the integration of v. What is v? I'm actually, first of all, I'm going to talk about d over dx. What is du over dx? Du over dx is f dash of x, because u is equal to f of x, so du over dx would be f dash of x. And what is v? V is equal to the integration of g of x. So v is equal to the integration of g of x, and I have another dx left here, which is actually going to be dot dx. Let me repeat that again. First I'm going to talk about what is du over dx. Du over dx is going to be equal to f dash of x, because u is equal to f of x. Then du over dx is actually going to be equal to f dash of x. So this is f dash of x. What is v? V is the integration of g of x dot dx. So instead of v, I wrote integration of g of x dot dx, and this dx was left here, so I've actually kept this dx right here. So this equation becomes, so I'm actually going to write this equation on the next page. We have integration of, I'm sorry, first I had f of x. So I had f of x into integration of g of x dot dx is equal to the integration of f of x into g of x dot dx plus the integration of f dash of x into the integration of gx dot dx, the whole of dx. Now since we're actually trying to find this, what I'm going to do is I'm actually going to make this as the subject. That means I can say that the integration of two functions, the product of two functions, is actually equal to the first function multiplied by the integration of the next function minus, because this is actually going to go there and become a negative number. So integration of differentiation of the first function into integration of another function and the differentiation of whole. Looks very complex, but it's very easy to understand. Just to put that in another case, the integration of u dot v dot dx is actually going to be equal to u into integration of v dot dx minus the integration of u dash into integration of v dot dx and the whole dx. Now, how does that help us? How does that help us to find the functions, the derivative of some function, sorry, the integration of product of two functions? Now, this is more of a reduction formula. Now, why do you call this a reduction formula? Because what happens is, let's say out of these two functions, the integration of u is kind of impossible. You're not able to find the integration of u. Then what happens is, you can actually see that you're not supposed to find the integration of u anywhere in this expression. So you kind of bypass that, right? So that is what you do. So that means you have a choice. You have a choice whether you want to take u here or you want to take u here. You can actually choose according to yourself. Let me take for an example. Let's say we have to find the integration of, so I'm going to start with a simple example here. Let's say we have to find the integration of 2x into e to the power x dot dx. Fine. So that is going to be equal to, if I just substitute that in the expression. So what was the expression? The expression was integration of f of x into g of x dot dx is equal to f of x into integration of g of x dot dx minus the integration of f dash of x into integration of gx dot dx and the whole dx. Now it's my choice whether I want to take e to the power x or whether I want to take 2x here. Now remember here, if I take 2x as the value of f of x, you can clearly see this f dash of x will actually become simply 2. So what will I do? I'll be able to reduce this function, isn't it? I'll be able to eliminate the value of x. So the same thing here to do is take f of x to be equal to 2x and g of x to be equal to e to the power x. So this will become f of x into integration of e to the power x dot dx minus integration of the differentiation of 2x, which is 2, into integration of e to the power x dot dx and the whole dot dx. So this is going to give me 2x into e to the power x, because the integration of e to the power x is e to the power x, minus 2 into integration of e to the power x is going to be e to the power x dot dx. This is going to be equal to 2x into e to the power x minus 2. The integration of e to the power x is simply going to be e to the power x, and don't forget to add a constant, which actually is a constant. Fine. So the c you have to add because this is integration, so you have to add a constant. So I hope you're able to understand what I'm trying to say here, guys. Becomes a pretty easy question at the end once you have to differentiate two functions together. Okay, so let's go ahead and do another question on this. Let's say I have to find the integration of log x. Now we've done so many videos on integration. Till now we haven't defined what is the integration of log x. We don't know the function whose we don't know any function whose differentiation will actually give you log x. We don't know any function. So what we're going to do here is we're actually going to treat one right here. We're going to take it 1 dot log x. And what we're going to do is, since we do not know the difference integration of log x, we're actually going to take this as this function. We're going to take 1 to be equal to g of x, and we're going to take log x to be equal to f of x. So this is going to be equal to f of x into 1 dot dx minus the integration of f dash of x. So that is the derivative of log x into the integration of 1 dot dx into dot dx. So this is going to be equal to log x. And what is this 1 dot dx? That is actually equal to x, right? So it remains like this, minus after that this is going to be the integration of integration of d over dx of log x. It's simply 1 over x. Fine. And d over dx of log x, it's simply going to be equal to 1 over x, and 1 dot dx is actually going to be x dot dx. So x and x is going to cancel each other out, so you're going to have x log x minus the integration of 1 dot dx, which is going to be equal to x log x minus this is going to be x plus a constant. So that is the anti-differentiation of log x, right? So if you find the derivative of this function, you're actually going to get this, which actually makes sense. So I hope you're able to understand what I'm trying to say here, guys. That's going to be pretty easy. Now let's try another question. Let's suppose I have to find the anti-differentiation of 4x plus 5 into ln of x. So how to do that? Now we have to choose which one we're going to take f of x and which one we're going to take as g of x. So if I take, now whose integration is difficult to find? The ln x differentiation is difficult to find. So I'm going to take this to be f of x and this to be g of x. So this is going to be equal to f of x, which is ln of x, into integration of 4x plus 5 dot dx minus the integration of differentiation of ln of x into the integration of 4x plus 5 dot dx into the whole dx. So this is going to be equal to ln of x. So if you differentiate this, this is going to give you 4x square over 2. I'm using the power rule here, plus 5 times x. I'm using the power rule here. 4x will become 4x square over 2. 5 will become 5x minus the integration of, what is the differentiation of ln of x, right? So the differentiation of ln of x, it's simply going to be equal 1 over x. So this is going to be 1 over x into the integration here. It's going to be same thing, 4x square over 2 plus 5x dot dx. As you can see, this x and this x and this x will cancel out because that's actually in the denominator, these are in the numerator. So this will become ln of x into 2x square plus 5x minus, now again we use the power rule, so 2x square differentiation is going to be 2x cube over 3 minus 5x plus c. Oh, I'm sorry, I've made a mistake here. I'm actually going to write it as another step. So this becomes 2x plus 5 dot dx. Let's do it in the next step. So this is going to be the same thing minus, so this is going to be equal to 2x square over 2, 2x square over 2 plus 5x plus c, obviously. I'm sorry, this is going to be negative here as well. Fine. So I hope you're able to understand what I'm trying to say here, guys. It was pretty easy. This was the most difficult step to do. Rest steps were pretty easy. So I hope you're able to understand what I'm trying to say here. Just to give you another thing for the last step, there is a negative here. This negative is going to make this negative. This negative is going to make this negative. 2x using the power rule becomes 2x square over 2. 5x will actually become 5, will just become 5x. So this is going to be the anti-differentiation or integration of this function. So I hope you're able to understand what I'm trying to say here, guys. So thank you very much for watching this video. I hope I introduced you to the integration by parts rule, and I hope this was helpful. And thank you very much, guys. So make sure that you explore our website, give us your valuable like to our Facebook page, and also if you have any feedback or suggestions, you can always email us at this email address. So thank you very much for watching, guys. I'll see you in the next.